So hello everyone, I am Michele Cosi and I will be the IT guy. I don't know how else to describe myself. I'm half Italian, half Thai, and for the ones that know how to read Thai, that's my Thai name. For the ones that don't know how to read Thai, it's pronounced Michele. And I'm here representing the University of Arizona and Cyverse. Cyverse is an organization that strives to help laboratories in the STEM fields to get to that cyber infrastructure that it is necessary for research. And Professor Cisades has done a very good job explaining why we would want to use supercomputers for research. However, I'm going to go over it, my talk again. So why? Why would you want to do that? Does anybody have any idea? Give me one reason why we want to use a supercomputer. I don't bite. You can yell. Speed! Yes, fantastic. Exactly. And do you know how we get that speed? More cores, fantastic. That is exactly why we would want to use a supercomputer. Speed, the availability of more cores, the availability of very fast GPU processors. GPU stands for graphical processing unit. But again, why would we want to do that? Because we live in the 21st century, and although we all have MacBooks, HP computers that have up to 4 cores, 8 cores, sometimes even 16 cores, sometimes the science that we want to do requires more. Maybe you are mapping a genome. Maybe you are, I don't know my molecular biology so well, but trying to understand how a molecule vibrates, for example, these things you can't actually do on your laptops. And therefore, we would use a supercomputer to do that. We are blessed to live in a moment where we can go from our laptops and desktop PCs to a room full of computers on the right. That is actually what a supercomputer looks like. It is not, it doesn't have a screen, it doesn't have a keyboard, and that's what we will be doing within the next 20 to 30 minutes. We'll try to get that screen, we'll try to get connected to a supercomputer. So yesterday, I sent out a short survey to test the waters and see what the computational ability of the group is. And I was very surprised. A lot of you have used SSH to connect a supercomputer before. Can I see a raise of hands of who was able to connect a supercomputer before? Yay. And leave your hand up if you have a Macintosh machine. That's about the same amount. If you do have a Windows machine and you were able to connect to an SSH, raise your hand. Fantastic. If you have a Windows machine and have never connected to a supercomputer, please raise your hand. Good. If you have not connected and have a Windows machine, I would like to see you later, because in order to connect to the service that I'm going to introduce in a second, we require a little bit of software installation and prerequisites. And that is only because of the OS. I have nothing against Windows, it's just it is a little bit more difficult to work around. So, what's going on? We're going to be using these 3 services: Exceed, Jetstream 2, and OpenStack. And what are these? Why so many names? Why is this so confusing? So these are actually very intertwined with one another, just that these are still services that are in a, how can I say, they're pretty novel. So they're not very well known outside of the sciences because these are services for scientists around the world. Exceed is a virtual system used to share computing resources. We're going to get to that in a little bit. Jetstream 2 is the cloud computing environment for researchers on OpenStack, and OpenStack is the cloud computing infrastructure. This doesn't answer any of the questions. This actually adds more questions. How do these three things actually communicate with one another? What are we actually going to be using? I hope this is how I see it. So at the bottom, we have OpenStack. OpenStack is actually the raw hardware, the bare bones, the metal, the GPUs, the CPUs. These are the actual supercomputers. And this is the room full of computers that I showed you earlier. However, we can't just go in there and connect a USB into a supercomputer and be like, hey, I'm connected. Especially if you have a room full of 45 students that want to do the same. Jetstream 2 is the service that helps with connecting and managing the hardware and software of OpenStack. This helps to compartmentalize, we call it virtualizing, but it's ideally compartmentalizing the computer resources that each one of you needs. And lastly, we have Exceed. Exceed is the allocation manager, and it basically tries to answer the question, how much of these can I use? For the ones that will not be using your own computers, we will be using Jetstream 2 virtual machines. Jetstream 2 virtual machines will be controlled by the Exceed allocations that Professor Travis Wheeler has arranged for us. And as it was mentioned earlier, these allocations will be running even after the workshop so that you can continue using this service on your own. So what we're going to be doing now is try to connect to these virtual machines. But before we do that, let me break it down a little bit more. This is a little bit of an infographic of what a supercomputer looks like. And in blue, we have the CPUs. You see a massive stack of CPUs on one on top of the other. And in green, we have the GPUs. You might ask, why do we need either one or the other? Well, that's because the software that you will be using are actually very computational intensive. Perhaps some of you will be assembling genomes. If this is bacterial genomes, maybe you can do it on your computer, but if these are human genomes, plant genomes, these things are massive. Who here has worked with plant genomes or human genomes? 1, 2, 3, 4, 5, 6, 7 people. There you go. And how much computational resources did you need in order to assemble genomes, these genomes? Do you know off the top of your head? Maybe not. I remember when I had to do my own research, I had to use, I think, something like 50 cores. And I don't think there is any computer out there that comes with a little laptop and be like, hey, here's 50 cores. And some of you will also be needing GPUs, as this will help with the molecular biology. I don't know any of it. My background is in plant biology and bioinformatics, not in chemistry. And the idea is that we're not going to be using an entire stack for one person. We're going to be using virtualization, so the compartmentalization, to split this supercomputer into different virtual machines. For example, here there are there's two examples. One, it's a virtual machine, one which only uses CPUs. Students here today that will only be using, for example, the genomics software will not be needing the GPUs and therefore will use the virtual machine version 1. Whilst the virtual machine 2 also does take some of the computational resources from the GPUs. For the MD students here, you will be assessing the second type of virtual machines. So talking a little bit about before talking about assessing the virtual machines, it is important that you understand that these virtual machines are on Jetstream 2. So these run on the supercomputer, and these burn allocations. Allocations is just like your cash. Allocation is your money. And this money is counted on exceed allocations. Therefore, in order to manage your money, manage your allocations, these machines need to be turned on and turned off. Machines that are on consume allocations, machines that are off consume less allocations, because even though you exist and you breathe and do nothing, you consume energy. So for the specifications of each virtual machines, these are running on Ubuntu 20. They have 8 CPUs. These can be changed to more if necessary. I don't think it is necessary at this point, but we can talk later on about the possibility of you running your own virtual machine, installing your own software, and therefore you can choose your own amount of CPUs that you want. Each machine has 30 gigabytes of RAM. And for the medical students, they use NVIDIA A100 GPU, which is a GPU unit, graphical processing unit of roughly 40 gigabytes, and that's pretty big. Lastly, and this is very important, each machine has 2 gigabytes of space left on them. Do not use the machines to run your programs. Instead, we're going to have shared storage. This shared storage is roughly of 1 terabyte, and I will show you, and you will try in a moment, to connect to your own folder in your shared storage. I also want to, it was mentioned before that these machines live on OpenStack, and these machines live physically in Indiana, in, I think, the University of Indiana, which is in, does anybody know where? And Bloomington, there we go. And that is roughly 14,000 kilometers from here, 8,700, which is the equivalent of 8,720 miles. There will be a little bit of lag. Please be patient. If you've ever played online video games, you will understand what lag and ping is. Okay, so how do you access your virtual machines? You access your virtual machines using Secure Shell, the Secure Shell protocol. And in order to access the Secure Shell protocol, you open the terminal. I will show you in a second. You type in your user at the IP address that will be given to you in a moment. If you are, for example, an instructor, you put instructor at IP address. If you are a user, you will put user number at IP address. If you are an MD student and require a GUI, a graphical user interface, we will be doing something called tunneling. Tunneling is a technique which allows you to bypass a port in your computer systems. Imagine your computer as being this room, and the doors are closed. But if you do tunneling, you basically tell your computer, hey, that's a door, open it for me. Without tunneling, you will not be able to access the graphical user interface. However, you can still use the GPUs on your terminal. This is only if you require a graphical user interface. That was my short presentation. Now the fun begins. All right, so I have created a Google spreadsheet, which I will be sharing with everyone on the Slack channel. I do also want to say, is anybody here not in the Slack channel? Yes, okay, one person is not in the Slack channel. Did you get an invite to the Slack channel? What was that? Okay, if you could get yourself on the Slack channel, that would be very helpful, because I will be sharing this list and updates on the Slack channel, availability of these virtual machines, when I'm shutting them down, when I'm turning them on. If you are running something, please do let me know so that I do not shut your machine down. And I will be sharing this on the computational, I think that's what it's called, computing resources channel. Give me a second. Mm-hmm. The passwords will be changed every single time the things turn on and off, so don't worry about it. So yes, that question was actually a nice question. How secure is this? This is live telecasted. How safe is this? Well, as soon as I turn off the machines and turn them back on, the password changes. So please do refer to this sheet daily, because I will be turning them off, turning them back on, and the passwords will change. The IP address will stay static. However, the passwords will change. Today, this is going to be a little bit of a trial run, but from tomorrow, the idea is that each one of you is going to have an assigned IP address, and you are going to be using that IP address throughout the entire workshop. This might change, as in everything usually changes, and therefore, do let me know if you run into issues. I have shared this with the channel, and please, you're going to find 2 pages. I don't know if you can see here at the bottom, but there is a VM access for genomics and a VM access for MD, MD being the medical students. The MD students, please put your username on column F. If you are an MD student, go to the second sheet and put your name there. If you are a genomic student, please go to the first page and put your name under the username. This will be your machine for the day and the machine where we're going to try to, the machine that you're going to try to connect to. If you're not an instructor, please do not use an instructor machine. Use a user machine. And the second column is going to be the password column that is going to change daily. Therefore, to connect, I have for example, an MD machine. I will go to my terminal. Let me make this bigger. Okay. I will type in SSH, my user 25, at the IP address. So I'm just going to copy and paste this IP address and enter. There might be a chance that you are going to be asked to put a fingerprint. In case that is asked, answer yes. In case you're not, well, you're probably asked, but once you're passed through that, just copy the password. So Control-C, Command-C, and just Command paste. The password will not be shown, but be sure it is actually there. You press enter, and there will be a it will output, hey, you have connected. If you want to connect through a GPU, please use a different SSH command, and we're going to talk about that in a second. But this means we are inside our virtual machine. If you have put your name in the Excel sheet, can I know if you were able to connect to your virtual machine? Okay, 1, 2. Is anybody having issues? I'm sorry, Windows user. We'll talk about it in a moment. Thank you very much. Are you also using Windows? Okay, right after this, we can sit down and I will show you how to run the Ubuntu subsystem for Linux, Ubuntu subsystem for Windows, excuse me, which will be the primary mode of connectivity for Windows users. If you have issues throughout the week and the workshop, please do refer to, for example, Professor Travis Wheeler over there, in case you have computational issues, or any other instructor that has a computational background. Once you are inside your virtual machine, as I mentioned a little bit earlier, please do not add large files within the machine, as there is only 2 GB left. Instead, we are going to change directories, navigate into our shared storage. The shared storage is in root data, CD, well, not root data, sorry, /data. This is where our shared storage is at. So inside your virtual machines, do cd/data. In data, I'm going to be listing, the listing command is ls. Please create your own folder. This is where your data is going to live. This is where you're going to be doing your processing. This is where you're going to be processing your work. It is also very, very important, please, that these that these folders inside the shared data have complete access. The way that you can check how much access you have is by doing df-h, for example. Oh, not df, sorry, ls-lh. And you can see here that my folder is the only one with both read and write the permissions. Please make your own folders read and write. And in order to do that, everyone here has sudo privileges. Everyone here is the root of your own machine, and therefore you do sudo change chmod, change permissions 777, and then the name of your folder. In my case, Cosi. There's a bit of lag. Yes. So even though you're logged into the same machine, you have a different IP address. Which one? Okay. You should be able to use sudo regardless. Yes. Ideally, yes, actually. Were you able to, 1, make your folder, and 2, change your folder permission to 777? Yes. Can I have a raise of hands if you were able to do so. 1, 2, 3. Who's having issues? Please raise your hand. Is anybody having issues with the internet? Oh, okay. Yeah, so there is an issue with the internet. Where is the IT guy? So, excuse me, everyone. So one thing that is going on is that people are losing internet, and that is because we are overloading the internet in this room. So if you are, please be patient. We are looking into it right now. I don't know exactly when this will be fixed, but try to connect to the internet, and if you do, do connect to your virtual machine, do create your folder, do change the permissions to your folder. I'll be right back. Hi, everyone. May I have your attention, please? So, there is a little bit of an issue with something called IP throttling. The IP throttling is not from our side. We're not doing anything wrong per se. It's just that the server on the other side is seeing many connections coming from the same IP address, and therefore it's thinking, wait, this is not right. I'm gonna cancel the connection. A hotfix for this will be installing a VPN. Please go to ExpressVPN. It will be 30-day free, no issue. So expressvpn.com. Download it, please, and install it. It will be free for 30 days, so it will be good for the duration of the workshop. And you shouldn't have issues later on, since you will be back at your own institution and will be connecting through a different IP address. But please, for right now, do download ExpressVPN and connect to a VPN server. This shouldn't take more than a minute. If you do have access to a different VPN, please use a different VPN. You don't have to use ExpressVPN. I just heard that it was free for a little bit, but it might not be the case for everyone. Okay, I apologize again for the connectivity issues that we are having. This was not foreseen. There are different routes that we can try to fix this with, and probably the best route is to try to whitelist on the server side this specific IP address, the connections coming from this IP address. For me to do that, I will take a moment, so 20 to 30 minutes. Please network. Please do the next part if it is possible. 1, 2, if you have a different way of connecting to the internet, using a different VPN, using the VPN from your own institution, using connecting to your house first and then hop onto this other server, please go ahead and do that. But we are going to try to whitelist this specific IP address such that we are not going to have this issue in the future. This is exactly what today was supposed to be about, trying to see the connection, trying to see if people can fail, try to see if people can succeed. So this is part of the workshop, everyone. Welcome to science.